Hello everybody. Everything is right. Yeah. Hello everybody. This morning I recorded a video for implementing a quicksort algorithm here. One of the implementation of this algorithm that I saw it here in this book, so I implemented myself, but using the same method and to see how it works and all of this stuff. But it was quite interesting. So I recorded for you in this morning, and you will see it in about a second. But I wanted to tell you that the voice of the record is a little sound of the record is a little bit low because it was in the morning. So please adjust it yourself and enjoy it. Okay, previously I was working on this recursion. It's implementing the quicksort algorithm from a book named this one, this implementation. I didn't want to implement this exactly, but I wanted to write my own code. And the thing was, my first implementation very bad. Was very bad, and I did some search and see where was the problem. And I had several problems here, such as wrong conditions, and it was very bad. This is wrong, and the implementation is very easy. Like um, the pivot was correct. We put a pivot here because we need a pivot, which is the value, the first index, which a log pointed to, and then the whole point is that, for example, if we have this kind of, for example, array, the whole point is we move from left and right, okay, because we choose the pivot to be this. We left a hole here at the low at this point, so we move from right to fill this hole. How? We first move from the right to left, and we check every other index, and if each of them were lower than this one, smaller than this one, we replace it with this, and then we move forward after the replacing. Then we move this one to here, the index of low to here, we fill this one, and here, and again we move from, because for example here we put 8 here, okay, so we remove this. We know that 6 is smaller than 8, so we put 6 here, but right now here we have a hole, and then again now we move from left to right, okay, to check this, and we do this back and forth until the index of low and index of high, they see each other, and at that point we finished the splitting. So we have the main while loop, we check that if the low is still smaller than high index, and then we have another while for moving from right to left, and we check this, that low is still smaller than high, and a high is, we check that if it is bigger or equal to pivot. Okay, at this point, let me write in one line. If this condition was the case, it is like this. We have 2 here, 3, 5, 5, another 5, another 4, and another 2, for example. So at this point we are moving from right to left, so it is like the first one is a hole. We need to fill this, and we are going to 5, 5, 5, 4, and 2. Okay, we check this. We know that low is smaller than high because low is here and high is here. So we check it. Pivot right now, and pivot for this example is 2. Okay, and we check because we want to fill this hole first. We check 2 is bigger and small and equal to pivot, and low is smaller than high. So we need to move another one, move another one, move another one until one of these condition, or high and low index, meet each other, or high is smaller than pivot. Okay, so for example, if the pivot was 1, was 3, this index, it has all the conditions, so we can escape this loop and replace and move these 2 to this position. Okay, see, we can replace these 2 with this position. Okay, because we want to make sure that every element at the left of the pivot, they are less than pivot, and every element at the right of the pivot, they are higher than pivot. Okay, so here we need to move it. If these 2 conditions shall exist, we need to move forward. Okay, we check the next element, check the next element, and at the end of it, if any of these conditions were not satisfied, it means that we find a value, or we find a value which is less than pivot, or low and high are equal. So at that point we fill the hole. Okay, and then we fill that. Then we saw a value at the left. The hole. Okay, so here we need to then walk from left to right. Why? Because let's imagine that we have 6, 2, 3, 5, 4, and at the first move, let's make it 7. At the first loop of this, we see that 7 is bigger than pivot, which is 6. Okay, we have a hole here, and the pivot is 6. You remember, pivot 6. we have a hole here. So at the first round, 7 is bigger than 6. So we check another element. 5 is smaller than 6. So we replace it here. And we, right now, we need to, because we replace it, here we made another hole. Because here we made another hole. So now we need to move low, index of low, forward. We need to check it forward to the right, from left to right, to see if any other index here is bigger than 6. If we find one, we put it here, because we made a hole here. So here we have 7, which we replaced it before. Then we have 2, which is not bigger than 6. We have 3, which is not bigger than 6. We have 5, which is not bigger than 6. For showing an example, we put 8, and before that we put here 9. So 9 is bigger than 6. Okay, so for it we make a hole here and we put 9 here. Then again at the low we add a hole. Then we check and we fill this and so on until these two meet each other at the one point. Okay, so this one will be exact same while like low is, we have to make sure low is less than high, and a low is smaller or equal to pivot. If this condition is true, it means that we didn't find any value smaller than. So we need the low to be plus plus. We didn't find any value which is smaller than pivot. So practically 3, 4, 5. Let me check it, control it. So here we have 8. Assume that here 4 is pivot is 3. Assume that pivot is 8. 4 is smaller than 8. Bigger than. Yeah, exactly. If it is still smaller, we have to move the low, because we need to find an element here which is bigger than pivot. If it's bigger than pivot, we need to fill it. That's the correct element to fill the hole of high. So if it is still smaller than pivot, we need to keep going and grow the low index. And then we can make the high index to be a low. Okay, we swapped. And this is the end of it. So this will continue and move forward until this condition reached the end. So when they are overlapping, it means that low and high are meeting each other. So it means that low is low moved enough to the right and high moved enough to the left, that they are now seeing each other. When they see each other, that index will be replaced with the pivot, and all element on the left are smaller than pivot, and all element on the right are higher than pivot. So here we need to say that, because low and high are equal to each other, a low or a high, doesn't matter, will be pivot. So done, and we return the pivot. Pivot is the middle element which we need. No, we return the low because here we need the middle, we need an index from low to that. We sort that in a good position, we return the low, which is the index of the pivot. Okay, then the index, for example, let's see, we have it like this. For example, 3, 2, let me 3, 2, 5, 6, 7, 5, then 7, 6, 8, for example. So low and high, they saw each other at this point, for example, and but all the elements on the right, they are smaller than 5, and on the left they are smaller than 5, and all elements on the right side they are bigger than 5. Therefore, we did a good split on this array, and then we need to do a quick sort again on a 2 sub array before the 5 here and after 5. I mean on 3 and 2, 3 and 2, and on 7, 7, 6 and 8. But for this we need to know the index of 5, index of pivot. 1, we move 1 forward to find 7 until the high, and move 1 back to find 2 from low, low to 2. Okay, we return this, and here split we will finish, and here we return it, and this. We do a quick sort again on each sub array, on the left side, which is this one, and on the right side, which is this one. And we do it again and again and again and recursively until this condition happens. And be careful that this low and high on this function, the general function, are different with the low and high in this split function here. They does not affect each other. They're just a copy of the value. And this was the previous one, which was not completely wrong, but it had a bad logic, but this one working correctly. I mean, like, I had an example, listen, I passed this, and but I passed this, and it was correct. I rewrote it again. And let's see. And I compile it again, recursion, give me like this one, 3, 2, 5, 7. Okay, let me make it like 5, 8, 7. Okay, 3, 2, 7, 5, 6 and 8, but I had a limit here. I can only, I changed it. I can only have 7. 1, 2, 3, 4, 5, 6, 8. We'll add another one here, which is 1. Let's go, baby. Yeah. 7, sorry. 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 5, 6, 7, 8. That's correct. It worked. So this is it. This is the correct one, and it's very compact. But it's very costs a lot because you have to recursively check all of the elements.